Namaste to all of you. Present we are doing the chapter Binomial Theorem. Already in this Binomial Theorem, basic part already given. And today, date 27th. Okay, you can follow this date so that you can understand either my video lectures are regularly are you getting or not. The topic name is Binomial Theorem. Okay, so already introduction part I given. In addition to that introduction part, a few bits also I given. Now today in this class I want to explain a few more concepts which are very useful for permutations combinations chapter also. Okay, so I will give one calculation today, very important calculations. So for example, NCR by NCR minus 1. What about this value? NCR by NCR minus 1. This is the value they given. Already NCR formula we know. What is NCR formula? N factorial by N minus R factorial into R factorial. This is the formula already we given. And N factorial you can write more. N into N minus 1 factorial. Like this also I can write. Already we given. And one more thing. For example, numerator N plus 1 factorial by denominator N factorial is there. What about this value? N plus 1 factorial means 1 into 2 into 3 into up to so on N plus 1. Denominator value 1 into 2 into up to so on N. So numerator 1 into 2 into 3 into up to so on N into N plus 1. By denominator value 1 into 2 into 3 into so on N. These both get cancelled. Directly you will get like this. Like for example 8 factorial by 7 factorial given. What about this value? 8 is the value. Okay, all these calculations we given, and one more formula also I given. NCR is equals to NC N minus R. So basing on this formula, for example 8C3 value. 8C3 value is nothing but 8C5. If you add these values now, it will be sum will be 8. All these calculations I given. Now today in this class I will explain one more important calculation. NCR by NCR minus 1. What about this value will be? Listen, first of all, note just one important point. Note NCR. What is NCR formula? N factorial by N minus R factorial by R factorial. Next, NCR minus 1 means what about that value will be? N factorial by N minus R factorial, of course, in place of R minus 1 is there, into R factorial. Now, this value will go to numerator. What you will get, tell me here? N factorial by N minus R factorial into R factorial. Here N factorial is there already. N factorial, and this value will go to numerator. So in numerator you will get N minus R plus 1 factorial into R minus 1 factorial. Now cross check. Is there any cancellations? Yeah. N factorial cancel. And here R factorial, R minus 1 factorial. So R minus 1 factorial, this factorial cancel. You will get denominator R. Next, if you observe this one. N minus R plus 1 factorial by N minus R factorial. Same means 9 factorial by 8 factorial plus 1 is there now. So if you cancel, what is the value? Therefore you will get which is equals to numerator value N minus R plus 1 by here denominator you will get R is the value like this. So here this is one important formula. Here the formula is, just note down this one, NCR by NCR minus 1 is equals to N minus R plus 1 by R. This is the one important calculation in binomial theorem. Of course, we can use the same formula in permutations combinations also. NCR by NCR minus 1 is equal to N minus R plus 1 by R is the value. Now, basing on this, one example I will give. 8C3 by 8C2. If they will give like this, NCR by NCR minus 1. If they will give like this, instead of N, 8 is there. Instead of R, 3 is there. Then what about this value will be? 8 minus 3 plus 1 by 3 is the value. Then what you will get, here it is 8 plus 1, 9. 9 minus 3, 6 by 3, which is equals to 2 is the value, like this. So this is one more important formula. NCR by NCR minus 1 is equals to N minus R plus 1 by R. Keep in our mind, this is as one formula. Okay. I hope that this is clear for you. Next. Okay, listen. Here one example is there. Here one example is there. Here the example is, if the coefficients of, next example, if the coefficients of x power 9, x power 10, x power 11 in the expansion 1 plus x whole power n are in arithmetic progression, then prove that n square minus 41n plus 398 equal to 0. This is one example bit more. Listen. If the coefficients of x power 9, x power 10, x power 11 in the expansion 1 plus x whole power n are in arithmetic progression, then our aim is to show that this is the relation. N square minus 41 into n plus 398 equal to 0. Listen here. So first of all, if you observe, what is the expansion for 1 plus x whole power n? 1 plus x whole power n is given by c0 plus c1 into x. Of course, here c0 means nc0. So nc0, nc1, nc2, I can represent like this also. Okay. So c1x plus c2 into x square plus so on plus cr into x power r plus so on plus last value cn into x power n. So this is the binomial theorem, already we know. With the help of the binomial theorem, if I expand the value 1 plus x whole power n, I can get c0 plus c1 into x plus c2 into x square plus so on plus cr into x power r plus so on plus cn into x power n. Now, according to data, what is the coefficient of x power 9? Listen. Therefore, coefficient of x power 9 comma x power 10 comma x power 11 are, what are the coefficients will be? If you observe here, x power r coefficient is cr. So, x power 9 coefficient is c9, nc9 you will get. X power 10 coefficient is c10 you will get. X power 11 coefficient is c11. These are in arithmetic progression already they given na. So according to data, coefficient of x power 9, this is the general term. So here x power 9 coefficient is C9 you will get, x power 10 coefficient is C10, x power 11 coefficient is C11. According to data, these three coefficients are in arithmetic progression. So arithmetic progression means, that implies, listen ma, if a comma b comma c are in AP, then what is the condition ma? 2b is equals to a plus c. This is the condition na. If a comma b comma c are in arithmetic progression, 2b equal to a plus c. So here you will get 2 times of nc10 is equals to nc9 plus nc11. You will get this one only now. 2 times of middle value equals to a plus c means this one. Now with this one, that implies you will get 2 is equals to, bring this nc10 value this side. Therefore nc9 by nc10 is the value plus nc11 by nc10 is the value. Now listen, since already just now we given on formula, ncr by ncr minus 1 is equal to, what is the formula? N minus r plus 1 by r. This is the formula already we given. Basing on this formula, how I can add this value? That implies, here I will write more. Listen. So here I will write, that implies 2 is equals to, this is reverse is there, NCR by, that means the first value I can add 1 by NC10 by NC9, I can write like this, plus second value, direct formula you can apply, NCR by NCR minus 1. So N is N value only, R value 11 is there, so you will get N minus R plus 1 by R, you will get that one. And what about this value will be, 2 is equals to 1 by N minus R plus 1 by R means 10 plus N minus 10 by 11 is the value. Now here, if you simplify this value, you will get, here it is. Tell me what you will get there. That implies 2 is equal to, this value goes to numerator, by n minus 9 is the value plus n minus 10 by 11 is the value. Take LCM value. 2 into n minus 9 into 11 equals to 11, 10 into 11 plus n minus 10 into n minus 9 is the value. Simplify ma. Here it is the value, 2 into 11, 22. 22n minus 22 into 9. What is the value, ma'am? This is the value. 22 into 9. Okay, this is the value. Equal to this side value 110 plus this is the value, ma'am, n square minus 19n plus 90 is the value. Now simplify. Our aim is to show that that is the value. So n square here as it is. Next, ma'am, minus 19n here it is. And here it is 22n. If you bring this value to this side, then what you will get, ma? 22 changes to minus 22 means minus 41n is the value, constant value. Ma. Here it is 200 is there, minus 198 changes to plus 198. So total value plus 398 is equals to 0. This is the result. So the entire bit is basing on the formula, this one, NCR by NCR minus 1 is equals to n minus r plus 1 by r. This is the formula. Basing on this formula, if you simplify, you will get the answer. I hope that this is clear for you. Okay. Next. Next, here it is one more example. This is also basing binomial theorem. Find the remainder. Find remainder when 2 power 2013 is divisible by 17. This is the bit. Find remainder when 2 power 2013 is divisible by 17. Listen, if you observe here 2 power 2013, this value I can write as 2 power 4 whole power. Can I write like this? Class check one time. 2013, you can divide with the 4. So due to that reason I given like that. So here till here it is the value 2012 you will get into 2 power 1 is there. So 2013. Okay. And here a power m whole power n formula. A power m whole power n means a power mn is the formula. So this value again I can write 16 whole power 503 into 2 is the value. So 2 into this is 16 value I can write as 17 minus 1 whole power 503. Understand, ma'am? Here they are asking what is the remainder when this whole value divisible by 17 they are asking. So I am proceeding like this. Now listen here. 2 into this is in the form of a minus b whole power n formula is there. So if you expand this total value, what you will get? Tell me. First of all, C naught into 17 power 503 you will get. Anyway, here minus is there. If the minus is there, alternately plus or minus terms you will get minus C1 into 17 power 502 plus on plus last but one term. What you will get here? C 502 17 power. What is value? 17 only you will get it, ma'am. There you will get 17 you will get. Now after this one, last value if you observe, what is last value? Minus C 503. This is the value you will get it. So if you observe here, till here in each term 17 is there now. So if you simplify, which is equal to, in each term 17 is there up to last but one term. This is the last term. This is the last but one term. Even in this also 17 is there. So you can common 17. If I common 17 here, what I can get? 2 times of total this value. C naught into 17 5 power 502 minus C1 into 17 power 501 plus 1 plus C 502. Till here you will get, this is the value, minus, listen, minus 2 times of this is the value. Means here and 503 C 503. What about this value? 1. Since NCN is equal to 1 already given. So minus 1 into 2 is there. So minus 2. So this whole value I can write as this whole value 17 into some q. This whole value, one integral value I can take as some q. Minus 2 is there. So this value I can modify 17q minus 17 plus 15. Can I write like this? Then simplify. 17 into q is anyway integral value minus 1 plus 15. So the whole value is divisible by 17 indirectly. 17 into some value. So automatically here what is the remainder you will get, mom? Therefore the remainder is equals to 15. Like for example, listen, mom. 15 when divided by 4, what is the remainder? Means how you can write? 4 into 3 plus 3. Can I write like this now? 4 into 3 means 12. If you subtract 12, what is the remainder value? 3 only. Na? This is the logic I applied there. So the whole value I can written as 17 into some multiple plus this is the remaining value. Means automatically what is the remainder value will be? 15 is the remainder value. I hope that this is also clear for you. Next. Next, here it is one more example. This is important model. If 7 plus 4 root 3 whole power n is equals to I plus f, where I and n are positive integers and 0 is less than capital F is less than 1, then show that I is an odd integer, and I plus f into 1 minus f is equals to 1. This is the one more example bit more. Listen. If 7 plus 4 root 3 whole power n equal to I plus f, where I and n are positive integers and 0 less than capital F less than 1 means f is the fractional value lie between 0 to 1. Then show that our aim is to show that this I is an odd integral value, and one more thing, I plus f into 1 minus f is equals to 1. So this is the one example they given. Listen. So first, what is the given data? 7 plus 4 root 3 whole power n is equals to I plus f, where I comma n are the positive integers, and this is the value where I is positive integer. This is already given. And one more point, what is they given? 0 less than capital F less than 1. This is the value they given. Now listen. For these kind of bits, 4 root 3. What is the 4 root 3 square value? Tell me. 4 root 3 square means 48. So 48 less than perfect square. Here also greater than perfect square. Nearer to 48 you have to take it. Because under root is there. Root of 48 means this is the value. So first of all, for this kind of bits, this is one method. So 48 I will take. How I can take 48 means squaring this one. If you are squaring this one, 4 square, 16 into root 3 whole square 3. 16 3s are 48. Less than and a closed perfect square number. What is the value? 36 is the value. And a greater value, which is the perfect square number, is nothing but 49. Then if you simplify, if you square it, if you take it, 6 is less than 4 root 3 is less than 7. Got it now? Now, here they are given 7 plus 4 root 3. So here I can take minus. Why I will take minus? You can understand later steps. So minus 6 is greater than minus 4 root 3 is greater than minus 7. Now, here the inequality is, that implies minus 7 is less than minus 4 root 3 is less than minus 6. Add 7 on each and every term. So if I add 7 I will get like this. This is the value I get. Okay. Now here if you observe 7 minus 7 0 less than 7 minus 4 root 3 is less than 1 is the value. Okay. Listen. Okay, sorry for interruption. So here first of all you can take 4 root 3. So if you multiply, this is the inequality. Add 7, you will get this one. How I can take this value? Basing on this value. Here 7 plus 4 root 3 they given. So I am taking 7 minus 4 root 3. And now listen. So this is 7 minus 4 root 3 lie between 0 to 1. 7 minus 4 root 3 lie between 0 to 1. So 0 to 1, if you take any value, if you increase the power, automatically the value also lie between 0 to 1 only. For example, 0 to 1 you can take some 0.2. What is 0.2 whole square value? 0.04. 0.2 whole cube value 0.008 means value reduces and always lie between 0 to 1 only. So in the next step I will write 0 is less than 7 minus 4 root 3 whole power n is less than 1 is the value. That is 0 is less than small f is less than 1, where here I am taking where small f is equals to 7 minus 4 root 3 whole power n. I can take this is the value. So this is the first value what they given. 7 plus 4 root 3 whole power n is equal to I plus f. And this is the value what I supposed to already capital F they given. So due to that reason I taken this value as a small f value. And small f value I am getting, this is the value. 7 minus 4 root 3 whole power n. Now in the next step I will do I plus f plus small f. I will do like this. Now I plus capital F plus small f. I plus capital F means what is the value? 7 plus 4 root 3 whole power n plus small f value 7 minus 4 root 3 whole power n is the value. Now if I expand this total value, here plus is there, so all the terms are plus you will get, but here minus is there. So if you expand here, nc naught 7 power n plus nc1 7 power n minus 1 into 4 root 3 plus 1. This is the first expansion value. Second expansion value nc naught 7 power n minus nc1 7 power n minus 1 into 4 root 3 plus 1. If I add these two, these plus minus terms get cancelled. So what I can get, mom? 2 times of c naught into 7 power n plus c2 into 7 power n minus 2 into 4 root 3 whole square plus 1. Like this you will get, mom. So this is the total integral value. This is the total integral value. One integral value into 2. What is the total value you will get? Even integer. So total value you will get, mom. Even integer you will get. So I plus capital F plus small f equal to some even integer I will get, mom. Till here I am getting even integer. Let it be equation number 1. Now listen. I plus f plus f. Anyway, this is integer value only now. We got here I plus capital F plus small f is equal to some integral value. Then what about this value f plus f value? capital F plus small f is equal to what you will get, mom? Integer value minus I. But according to data, what is I? Till now we are not using this point. I is a positive integer they given. So here integral value minus integral value. So total value what you will get, ma? Integer. That means here one more important point is capital F plus small f is also integer value we are getting. Integer value. Let it be equation number 2. Got it, mom? Now once again I will explain more. Enter this value. Here the data they given. 7 plus 4 root 3 whole power n is equals to I plus f they given. According to data they given, I is one positive integer value, n is a positive integer value, and a capital F will lie between 0 to 1. That is they given already. Where I is positive integer, this is the data they given. Now I will consider one value of 48. How I can consider that value? 4 root 3 whole square value. What is the 4 root 3 whole square value? 4 square 16. 16 to 3 48. Less than 48 a perfect square number. Nearer to 48. And greater than 48 very close perfect square number. Then I can take root value. I can get like this. Here they given 7 plus 4 root 3. So I am making 7 minus 4 root 3. This method you know. After that I will get 7 minus 4 root 3. Lie between 0 to 1. So 0 to 1, if you take any value, if you rise the power values, always the value also belongs to 0 to 1 only. So here 0 is less than 7 minus 4 root 3 whole power n is less than 1. And this value I can take as a small f. Okay, I given here where small f is equal to 7 minus 4 root 3 whole power n. Either small f or anything you can take it. Here I am taking small f. Now I plus capital F value, this is the value they given already. Small f value, I am considering this value 7 minus 4 root 3 whole power n, where n is positive integral value. Now add all these two. I plus f plus small f, I can get one even integral value. That means I plus capital F plus small f is equal to some integer value I am getting. But here according to data, I value they given integer value. So automatically capital F plus small f is equal to integer minus integer. Integer minus integer means anyway again integral value you will get. So till now what we got, mom? Capital F plus small f is a integral value. Till now we got this is the value. Now listen ma here. In the next step, how I can proceed? I will cut this value. Listen, since 0 less than capital F less than 1, already they given this is the value, and 0 less than small f less than 1, we got that is the value. By adding these two quantities, if I add these two quantities, what I can get? 0 less than capital F less than, capital F plus small f less than 1 plus 1. But what I got here according to second, but by second equation I will get capital F plus small f is integer value. I got it now. I got integer value. So capital F plus small f is integral value, and which is lie between 0 to 2. So obviously what is the possibility for capital F plus small f, mom? Simple, only one possibility is there, that implies capital F plus small f is equal to 1. Got it now? This is equation number 3. Now if this is 3, third equation, second equation what you will get, tell me? Second and first equation you can take it. First equation, from the first equation there you will get I plus capital F plus small f is equal to, even you are getting already, but capital F plus small f is equal to what we get? 1 is the value. So that implies I plus 1 is equals to even. We are getting this is the value. I plus this value already 1. Then I is equal to what is the value? Even minus 1, which is equals to odd. That is, I is an odd integer. I is an odd integer. Our aim is to show that this is the value. Then show that I is an odd integer. I is an odd integer. So till there it is completed. Now next part. What is the next part will be? In the next part, ma'am, this is the value. I plus capital F into 1 minus capital F. This value we have to find it. But what is the value I plus capital F value? According to data, I plus capital F is equal to, this is the value, means 7 plus 4 root 3 whole power n into, how this value will be? 1 minus F. Here from the third equation, listen here. From the third equation implies capital F plus small f is equal to 1. The small f equal to what is value? 1 minus capital F. Na? That means 1 minus capital F means I will write small f value. So 7 plus 4 root 3 whole power n into small f value. What we got small f value? The small f value I taken as 7 minus 4 root 3 whole power n. Now whole power n common you can write. Then this is 7 plus 4 root 3. This is 7 minus 4 root 3. A plus b into a minus b. What you will get? A plus b into a minus b means a square minus b square, means a square minus 4 root 3 whole square whole power n as it is. Then simplify this total value. 7 square means 49 minus, this is the value 48. 49 minus 48, 1. 1 power n means 1 is the value. So this is the second bit. I plus f into 1 minus f is equals to 1 is the value. So this is the bit, mom. Subjective point of view important. So first of all, here they will give 7 plus 4 root 3 whole power n is equal to I plus f. Already they given I is integral value. N is also positive integral value. Capital F will lie between 0 to capital F less than 1. Our aim is to show that I is odd integer. In order to prove that I is odd integer, so first of all here 7 plus 4 root 3 they given. I estimate the value 7 minus 4 root 3 value. How I can estimate 4 root 3 value? First square it. 4 root 3 square. 4 root 3 square means 48. So 36 less than 48 is less than 49. Perfect squares which is immediately below this number. Perfect square which is immediately greater than this number. Then as it is, 6 is less than 4 root 3 is less than 7. My requirement is 7 plus 4 root 3 they given. My requirement 7 minus 4 root 3. So minus 7 is less than minus 4 root 3 is less than minus 6. Add 7. 0 less than 7 minus 4 root 3 is less than 1. 0 to 1 if you take any value. If you increase how many powers? Obtained value also lie between 0 to 1 only. So 0 is less than 7 minus 4 root 3 whole power n is less than 1. Then this value I can take as small f is the value. Then by considering this small f value as 7 minus 4 root 3 whole power n, then what I did, mom? I proceeded in this manner. I plus f plus f. If I did I plus capital F plus small f, I will get the value as some even integral value. So I plus capital F plus small f equal to even integral value. Means anyway integral value. I is already integral value. Bring this I value this side. Then capital F plus small f is equal to integer minus integer. So means capital F plus small f value and integral value you will get. But now capital F value lie between 0 to 1. Small f value also lie between 0 to 1. Add them. If I add them, I will get 0 less than capital F plus small f less than 2. So capital F plus small f value lie between 0 to 2. And this is integral value. Means what is the possibility? capital F plus small f is one only possibility, since 0 to 2 between one only integer. So this is the value. Now I plus capital F plus small f is equal to, first equation what it is saying, this is even integral value, but capital F plus small f value 1. So bring this total value this side, then I is equal to even minus 1. Automatically 1 even integral value, if you subtract 1 you will get the odd integral value. So automatically here it is I is an odd integer. So this is the first part, it is completed. Next our aim is to show that I plus f into 1 minus f value. Simplify that value also. I plus f means this is the value. 1 minus f, this is the value. Replace the values, f value you know. So power n common. Then 7 plus 4 root 3 into 7 minus 4 root 3. Use the logic a square minus b square. You will get the value 1 power n, which is equal to 1. Okay. I hope that this is clear for you. Okay. In the next class, few more examples we will discuss now. Thank you.